Well, hello guys, here Mr. G with another question. This time is for the grade 10 and it's related to energy, therefore it's also applicable for the grade 12. This was question 5 done in November 2022 in the Gauteng province. But before we carry on with the question, subscribe for the channel so you can get the notification of all the videos I post on regular basis. This question say a roller coaster cart of mass 2 kg is released from rest. Now important, note here, is released from rest at point A. So the velocity at point A or speed is going to be equal to 0 because it was at rest. And that one is 30 meters above the ground. It's showing you there. So I'm going to call this one A, for example. All right. The cart moves along a frictionless surface. There is not friction. This means that the system is closed. Right, system closed, because for this word you need to know that the system is closed. Surface A, B, C as shown below. You have also here, this one is high B equal to 10 and high C is equal to 25. The question says define the term gravitational potential energy. So let's write down that definition real fast and let's do it here at the bottom there. And this definition states that energy of an object, the potential gravitational energy, the energy of an object as a result of its position above the surface of the Earth. And this definition, guys, will give you 2 marks. You have to learn the definition. Question 5.2 is proof with calculation that the mechanical energy of the cart at point A is 588 joules. So let's answer that one real fast. And this one is quite simple. It's 5.2. Now, the first thing we're going to do is to go to the formulas. Now, here in the formulas, which is at the end of the question paper, I'm showing you all the formulas there. Here, this formula is for mechanical energy. You can see that mechanical energy is the addition of kinetic plus potential. So the first thing we're going to do is to write that formula. Mechanical energy is equal to kinetic energy plus potential energy. All right. Now, if you remember, kinetic energy, which is also there, the formulas, is half multiplied by mass multiplied by the speed squared plus mass multiplied by acceleration due to gravity multiplied by height. And the question set at point A. So all this one is for A. All this one is at A. Okay, so now we are going to substitute what we have here. All the data is given to us here is 2 kilograms. So let's substitute this one. Mechanical energy is equal to half multiplied by the mass, which is 2 kilograms. The speed, remember the object start moving from rest, so it is 0 squared plus 2 multiplied by 9,8 multiplied by the height, which is 30 meters, is given to you in the picture. And then when you calculate that, you will get that mechanical energy is equal to 0 plus 588 joules, and therefore the mechanical energy is indeed equal to 588 joules. That is the answer for that specific question here. There is 3 marks for that, guys, and if you do that one in that way, where will the marks come? The first mark is for this formula, which is given to you at the end of the exam, so you should not be making the mistake. Second mark is for the substitution of everything. Is quite simple because all the values are given you there. And at the end, the final mark is for the final answer here, which is quite simple. Question 5.3 states the law of conservation of mechanical energy in what is a very easy definition. That one, a very easy law to state, and is important for the grade 12. This law is 5.3. This law, I'm going to write the answer here. And this law states that the total mechanical energy is conserved in an isolated system. Guys, very easy definition, very important not only for the grade 10 but also for the grade 12. The word total must be there, please. An isolated system must be also there. It's very important words. So if you state everything but you miss those words, you don't get full marks. So this is another 2 marks here. Let's go to question 5.4. Calculate the velocity of the car when it is at point B. Now for this one we have to use the law. And we are going to come here. Now the law says that if the system is closed, the mechanical energy doesn't change. In other words, the change in mechanical energy is equal to 0. If mechanical energy does not change, it means that the total mechanical energy initial is equal to the total mechanical energy final. Instead of initial and final, I'm going to erase that one and I'm going to write A and B. Alright, now mechanical energy, remember, is kinetic plus potential. So the mechanical energy at A will be the mechanical energy, the kinetic energy A plus the kinetic energy, potential energy A, but that one was already calculated, so I'm going to leave it there. And at B, we have that is the kinetic energy at B plus the potential energy at B. If we carry on substituting here, we have that mechanical energy at A, I'm going to leave it like that for now. Kinetic energy at B is half mass multiplied by the speed square at B, right? Square plus mass acceleration due to gravity multiplied by height at B. And guys, the rest is substituting what we have. Mechanical energy at A is 588, is given to us, and we did calculate it. We proved it that it was correct. The mass is 2, the speed square, that is what we are looking for. We are still looking for speed. The mass is 2, it's not equal, it's a plus. Mass is 2, 9,8 multiplied by the height at B, which is going to be, let me look quickly, 10 meters. You must go to the picture. It is in the picture. So when we do this calculation, so far we have in 588 is equal to, divided by 2 is 1, so it's B squared plus 196. When you rearrange, you will get that the speed B squared is equal to 588 minus 196. This is equal to 300, this is a square, is equal to 392. Now we have a square on one side, so we're going to get the square root on both sides, guys. This one will cancel there, and you will get that the final answer for speed at B is equal to 19,8 meters per second. And that is the solution to this question, applying the law of conservation of mechanical energy. Quite simple. I hope you understand this one. Mark wise, where do you get marks here? Well, there's 1 mark for starting here. Say mechanical energy, you can start with either one. Mechanical energy at A is equal to mechanical energy at B. You'll get 1 mark for substituting the 588. You'll get 1 mark for substituting all these values here on the right side, which is really easy. And then you'll get 1 last mark for the final answer in the equation. And just to finish this question, how will the mechanical energy of the car at point C compare with the mechanical energy of the car at point B? Write down greater than, less than, or equal to. Guys, we go we go again to 5.3. It is going to be conserved. So all of them, all the mechanical energy will be the same. If you come to the picture and the mechanical energy here is equal to 588 joules, the mechanical energy at B is 588 joules, and the mechanical energy at C is 588 joules. Is the same because the system is isolated. This is mechanical energy. That is important to know. So the mechanical energy is the same everywhere. So you have to say is equal to, give a reason for your answer. Mechanical energy is conserved. All you have to say is that mechanical energy is conserved. And this one is the end of this question. Quite simple. I hope you understand, and I hope it helped. Thank you for watching, guys. Thumb up, and don't miss the next video. Next video we're going to work with wave. We're going back all the way to speak about waves, and it's important topic for the test. But thank you for watching. Thumb up, subscribe for the channel. I'll see you next time. Mr. G here.